mindful of what they are doing. And fortunately, I tend to be very mindful in caves. Yes, I close my pinky finger on our front door. So, yes, accidents do happen, but we're all hopeful that will be the extent of our accidents this mission.
Well, once again, thank you, and keep having a great time, and watch those doors.
I sure will, Matt. Thank you so much.
Jut Wynne is down with a team exploring the caves of Chile in preparation for exploring the caves of Mars. He's down there for the Carl Sagan Center at the SETI Institute. He is also with the United States Geological Survey, Southwest Biological Science Center at Northern Arizona University, and the Colorado Plateau Museum of Arthropod Biodiversity, also at Northern Arizona University.
Hi, I'm Emily Lakdawalla with questions and answers. A listener asked, what is an E-type asteroid? E-type asteroids are in the news because of Rosetta's plans to fly past one, Steins, on September 5. They are common in the very inner edge of the asteroid belt, but they are very rare elsewhere. That location at the inside edge of the asteroid belt gives them a unique composition, because it means they were born under hotter conditions than most asteroids. They probably have more rock and metal and less volatile elements than most asteroids do. They are to the rest of the asteroid belt as Mercury is to the rest of the planets. Most meteoriticists link E-type asteroids to a type of meteorite called an aubrite. Aubrites are weird because they are igneous rocks made of almost entirely one mineral called enstatite, hence E-type asteroids. E is for enstatite. That composition means they probably came from the mantle of some much larger ancient asteroid that had a rocky mantle and a metal core. This isn't unheard of. There are other types of meteorites that probably came from the crust, mantle, and core of Vesta, a huge asteroid that seems to have been blasted in half by an ancient impact. The problem is that we've never seen anything but the mantle of whatever body the aubrites came from. Are they really the mantle of an ancient body, or are they some weird type of rock that somehow formed on its own? Perhaps once Rosetta has visited an E-type asteroid, we'll have some answers. Got a question about the universe? Send it to us at planetaryradio@planetary.org. And now here's Matt with more Planetary Radio.
Time for What's Up on Planetary Radio. Bruce Betts, the Director of Projects for the Planetary Society, going to give us yet another tour of the cosmos as we work our way toward another trivia contest answer as well. I'll keep my arms and legs inside the car.
Please do. When you look up in the sky, what are you going to look for?
Jupiter?
Hey, this guy's been paying attention. I just like to test you once in a while. Thanks.
Still?
A lot of Jupiter. A lot of Jupiter for a long time.
Okay.
It's really good. Look over in the east after sunset. Anytime in the evening, look high up. It is the brightest star-like object up there. And encourage you to go take out even binoculars held steady, but certainly a small telescope, and you can see the Galilean satellites, the 4 largest moons of Jupiter, named after that Galileo guy. And they will appear in a line, although you may not see 4 because they may be in front of or behind Jupiter. You can find predictions of which ones are on which side at which time. You can identify them. You can invite your friends. It's great.
That's kind of like obscure baseball statistics, having to know where the Galilean satellites are going to be,
Hey, it's important. Unfortunately, they rarely try to steal second.
I'd say it's important to, the Cassini folks.
It's important if you're studying them.
Okay, absolutely right. But for my backyard telescope party,
if you want to impress people at your
backyard,
backyard telescope party, and then go, which one is that 1 second to the right?
And you go,
right. Bob. Then they're going to probably not be impressed.
You're absolutely right. I stand corrected.
Of course. Now I'm glad we've taken care of that. It was good we did, because there isn't a whole lot else to look at. There are all sorts of planets still clustered. But they're even lower than last time I told you about them. But low in the west, shortly after sunset. Pull out the binoculars, look for Venus, Saturn, Mercury doing a dance. Venus is the brightest, will be the easiest to pick out.
Planet
Mars
X.
to the upper left of them. Planet X, the airplanes taking off. You might catch them all clustered in the sky, low in the west. Look 20, 30 minutes after sunset, maybe with binoculars.
All right, I'll try.
On to This Week in Space History. A lot of launch stuff in space history. But among the launch stuff, there was the second woman in space in 1982, Svetlana Savitskaya. We also had launches of Viking 1 in 1975, Voyager 2 in 1977, and a plethora of other lesser-known spacecraft objects. So that's the good stuff going on in space history. We go on to Random Space Fact!
Ooh, I love that. I love how it built there.
Geostationary satellites.
22,300.
You rock. I'm glad I'm not asking that as the trivia question this week. But I have another one. We'll see if you know that. Geostationary satellites stay over 1 point at the equator of a planet, matching the rotational speed. People like to use them for things like television, sometimes communication, but it's so far away. Causes a quarter-second delay, half-second delay, and depending on how long it processes on board. And indeed, the altitude of a geostationary satellite is
22,300
miles.
Meters. Miles.
Miles. They're way up there.
Yeah, I know.
That's 35,800 kilometers approximately. And my point is, hey, they're way out there. That's like a tenth of the way to the moon, but perhaps more in your head. That's like 10 times higher than the International Space Station.
Very cool.
So you have to get out there. That's the altitude where their natural orbital velocity matches a point moving around on the surface.
Wait a minute. 10 times higher than the space station or 100 times higher? 22,000 miles, 200, 2,000.
Yeah, okay.
Okay.
I was only an order of magnitude off.
Did I catch you? I caught you in one? I'll be darned.
Busted.
Good work, Matt.
Nice job, Matt.
2 orders
yes,
of magnitude.
good job.
Thank you.
No, I mean, gosh, they really are way out there. They're 100 times farther from the surface of the Earth.
Made my day.
Than International Space Station. Congratulations.
Thank you so much.
I just put that error in there to see if, you could catch it.
Do I get a poster?
You're doing great Sure. Take a poster.
Okay.
I think there are ones that are kind of beat up around the edges. Grab one of those.
All right.
On to the trivia contest. We asked you last time around, what was the first successful balloon mission in the Venus atmosphere? How'd we do?
Chuck Lund did well. Chuck Lund of Otsego, Michigan. Otsego? Mangled, I'm sure.
Do we have to ask pronunciations?
He didn't give
for
it.
The cities now?
It would be helpful, yes. But Vega 1, an old Soviet mission.
Indeed, Vega 1, followed by Vega 2.
Lasted a couple of days, which to me is just incredible. In that environment, floating around in that nasty, nasty place.
It is a nasty place, but that's partly why you do balloons. You stay up above the even nastier surface.
Yeah, okay.
Still, very cool and learned a lot of good stuff. So congratulations. We go on to the next trivia contest.
Can I just mention Chuck's going to get an Explorer's Guide to Mars poster?
Yes, you can mention that.
Did I say
his
Mars?
Will not be beat up.
Yeah.
Well, you kind of said Mars.
I'd Mard or something like that.
Why don't we give him the one that has like a map and pictures of Mars?
All right.
In fact, let's give it to the next person if they can answer this question, which is not 22,300. What was the first geostationary satellite? Take that.
I do know this one.
Oh, well, don't say it.
All right. They've got, well, tell them how to enter first.
Go to planetary.org/radio, find out how to send us your entry.
And you've got until Monday, 2 p.m. Pacific on August 25. Monday, 2 p.m. Pacific on the 25th. We're done.
All right, everybody, go out there, look up the night sky, and think about the sound of wind passing through a pine tree forest. Thank you, and good night.
Let's just enjoy that for a moment. He's Bruce Betts, the Director of Projects for the Planetary Society. He's with us every week for What's Up? The Ulysses Mission, next time on Planetary Radio. Our show is produced by the Planetary Society in Pasadena, California. Have a great week.